talking about stretching and shrinking our graphs. There are two options. There's horizontal and vertical. In general, with our transformations, anything on the outside is vertical. It's changing y. And it does what you think. Anything on the inside is horizontal. It's changing x, and it does the opposite of what we would normally think. So vertical stretching and shrinking happens if you multiply a number on the outside. And it does what we think. If that number is bigger than 1, it's stretching it. If that number is smaller than 1, it's shrinking it. Horizontal is when the number is inside. And it does the opposite. If you multiply by something bigger than 1, then it actually will shrink your graph in horizontally. If you multiply by something smaller than 1, it actually stretches it out horizontally. The horizontal stretching and shrinking is usually the most difficult portion to think about when we talk about transformations, and you do have the option, if you really get confused, you can always go back to making a t-chart or something to double check yourself on that. So let's look at some. When I ask you to graph with transformations, I will expect a parent function and the final transformation, always. I want a minimum of 3 exact points on each. So we did 2x cubed. We did x cubed yesterday, right? That's my parent function. What does x cubed look like? A chair. So minimum of 3 points. 0 cubed is 0. 1 cubed is 1. Negative 1 cubed is negative 1. You can do more if you need to. I want the parent function dashed. I want to be able to tell the difference between the two. So if we all use the same notation, then you don't have to label it. This 2 is on the outside. The cube does not apply to it. We're going to take x cubed. Once I get that, then I multiply it by 2. So that is a vertical stretch. It's taking my y values times 2. So if I look at my graph, take those 3 points we have. This point is a y value of 0. 0 times 2, does that move it? No. This is a y value of 1. 1 times 2 is 2. What's the y value right here? Negative 1. So negative 1 times 2 will give me a negative 2. So my final graph, when you stretch it vertically, just like when you stretch a rubber band, the more you stretch it, the skinnier it gets. That's what's happening here. As I stretch it out, it's getting skinnier. If I look at B, so 1/2 x cubed. Same parent function. So we can put our 0, 0, 1, 1, negative 1, negative 1. And then what does the 1/2 do? It's outside, so it's changing the y. It's just like multiplying your y's by half, so it'll be a vertical shrink. Now, if you have something and you take it to half its height, it should get shorter. So we take our y values times a half. 0 times a half is still 0. 1 times a half is 1/2. Negative 1 times a half is negative 1/2. When you squish it down, it gets shorter and fatter. questions right there. So for this one, my function is the square root of x. So let's graph that parent function. What's the square root look like? Yeah, just that little curve. You can't plug in negatives. Square root of 0 is 0. Square root of 1 is 1. Another nice number, you could do the square root of 4 is 2. So it looks like that. So f of 3x means the square root of 3x. Okay, I told you inside is horizontal. It's changing our x, but it does the opposite of what you said. Okay, so even though this says take x times 3, what that actually does on my points is like dividing my x's by 3 when I talk about how it changes my graph. Inside always does the opposite. So, this point has an x value of 0. 0 divided by 3 is still 0. This one has an x value of 1. 1 divided by 3 is 1/3, so it's going to move my x back to a third. Okay. This has an x value of 4. 4 divided by 3 is 4/3, so it's like 1 1/3. What this did was a horizontal shrink. Inside is opposite, so the 3 shrink it horizontally. Now if you take something and you mash it horizontally, what happens to the height? The height's going to go up. You know, so I took it and mashed it in, so it got shorter and taller, essentially. What if you got confused on that and you weren't sure what to do? You have a graphing calculator you could use to double check yourself. If I want the exact points, could you make a t-chart and plug in some numbers and get it that way? Absolutely. So, when in doubt, go back to the other things that we know. Second one, I want f of 1/3 x. So since that 1/3 is smaller than 1, we know it does the opposite. This is going to be a horizontal stretch. Okay, so it's essentially going to take my x's and divide them by 1/3, which is the same as multiplying by 3. So we start, this has an x value of 0, and 0 times 3 is still 0. This had an x value of 1, so where does that move to? 3. Okay, here we had an x value of 4, so it's going to go to 12. See if I have enough space here. So that horizontal stretch, when you took that graph and stretched it horizontally, it got long and skinny, or shorter and longer. Questions? 1/3 x squared. What's my parent function? X squared. What's that look like? Parabola. 0 squared is 0. 1 squared is 1. Negative 1, 1. You can do more if you want. I just told you minimum of 3. Okay, is that 1/3 affecting x or y? Y. It's on the outside. It's changing my y. So it is a vertical, and outside does what you think. So the 1/3 will shrink. So outside does what you think. You just take your y's times the third. So 0 times the third is still 0. 1 times 1/3 is 1/3. 1 times 1/3 is 1/3. So a vertical shrink makes it get shorter and fatter. B. Same parent function. Okay, the 4 is on the inside, so is it changing x or y? X. So it's a horizontal, and it does the opposite. So 4 is bigger than 1. That means I would expect it to stretch, so it actually shrinks. So essentially what we do is divide our x's by 4. So this is an x of 0. 0 divided by 4 is still 0. This point had an x of 1. 1 divided by 4 is 1/4. Here you're at negative 1. Negative 1 divided by 4. Horizontal shrinking and vertical stretching look a lot alike, don't they? If we had just squared that, we would have had 16x squared, and then it would be a vertical stretch. So they're very closely related. C. What's an absolute value look like? V. 0, 0, 1, 1, negative 1, 1. You can do more points if you want. 2, 2, negative 2, 2. Enough to feel comfortable. Okay. It's inside, so it's horizontal. Does the opposite. So 0.25, I would expect that to shrink, so it will actually stretch. So what you're doing is taking your x's, dividing by 0.25, which is the same as multiplying by 4. 0.25 is 1/4. So dividing by a 4th is like multiplying by 4. X value of 0 won't go anywhere. Here x equals 1. 1 times 4 is 4. This is when x is negative 1. Negative 1 times 4 is negative 4. Alright, last one of these. X to the 4th, it wasn't one of my parent functions that I made you guys do yesterday. But we can get a graph. 0 to the 4th is just 0. 1 to the 4th is 1. Negative 1 to the 4th is 1. What's 2 to the 4th? 16. I don't really want to graph that, but can you tell what this is going to look like? It's just a skinny parabola. That's all it is. So enough to get our parent function here. Okay, what's the 5 going to do? So it's like multiplying your y's times 5. So 0 times 5 is still 0. 1 times 5 is 5. And then over here, that's 5 as well. And so we get our graph. Any questions for me on that? Next type of transformation I want to talk about. Reflecting, flipping your graphs. That happens when you have negatives. So a negative on the outside changes y. If you take a point and you make the y negative, it flips it over the x-axis. Okay, inside is x. If you take an x value and you make it negative, it flips it over the y-axis. Vertical translation, if you add or subtract on the outside is y, it does what you think. So adding moves up, subtracting moves down. If we add or subtract on the inside is x, it does the opposite. So subtracting from an x actually moves it to the right in the positive direction. Adding to an x moves it to the left, moves it in the negative direction. Alright. So I've got graphs here. We're just going to practice parent functions and what these things look like. So the first one, what's my parent function? So 0 squared is 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. So then, a negative on the outside. Outside is y, so it's saying you take your y values and you make them negative. So what will this do? So flip over the x-axis. If I take 0, 0 and flip it, it doesn't go anywhere. These points just come down. So it should look like that. B, a square root function would be our parent function. So square root we know starts 0, 0, 1, 1, 4, 2, 9, 3. Do you guys all know where I'm getting these points? These were our common functions that we were working on the past 2 days. Okay, this time the negative is on the inside. Inside changes x. If I take my x and make it negative, what does that do? Over the y-axis. You take each point and you do the opposite of its x value. This one will come over here. And this come over. So you just get your mirror image on the other side. I want you guys to do the next slide. value is your v. Negative on the outside makes y negative, so you flip over the x-axis. So that's just going to flip your graph upside down. X cubed is the chair. Negative on the inside says make your x negative, so it flips it over the y-axis. A minimum of 3 exact points when you do that. Any questions there? Alright. Let's look at this one. So we know x cubed is our chair. Same parent function we just got done with. This time I'm adding 4. If you add 4 on the end, what is that going to do to my graph? It's outside because it's not attached to the cube. It's on the end, so it's changing y and it does what we think. So we're just going to go up 4. Again, if you ever weren't sure, what would you do? Graph it on your graphing calculator and double check. Plug in some points and double check. We have options. B, the absolute value of x, we know that's the v. What would the minus 2 do here? Down 2. Probably the up, down, left, right is probably the one you remember the most. We really, in Algebra 2, you really only did this with parabolas and absolute values. You didn't do it with all of the functions, so we have more things, but the transformation rules didn't change. Okay, I'm probably not going to do all of the ones on the next slide. I want to do, let's do B and C. Just looking at A, can you tell me what the transformation would be? Up 1. Okay. B, what's my parent function? Square roots. So we know square root of 0 is 0, 1, 1, 4, 2, 9, 3 if you wanted to do that. So there's your square root. Inside is x, so it does the opposite. If I subtract from my x, it actually moves it to the right. So we're going to go right. Add to x, go left. You subtract from x, you go right. So move each of these points to the right one. This one, what's my parent function? X squared, so just your parabola. What's my transformation? Left 3. I'm not going to do D right now, but what would that transformation be? Down 4. Okay. Let's look at this one. I gave you a hint on this and told you to factor first. What can you pull out of this? A 2. Can I take it all the way outside my absolute value? Can you do the absolute value of 2? What is it? 2. So essentially what I'm saying, you could make this a 2 and then x minus 2. And we know the absolute value of positive 2 is positive 2. So you could pull it all the way out. So this one, what's my parent function?
Absolute value of A.
Absolute value, the v. We're going to be really good at graphing all these before we're done. Now, my transformations. This time I have a couple of them going on. What's this 2 on the outside do? And what's this 2 subtracted from my x do? Okay. So, it's a 2-step process. I take my point. Vertical stretch of 2 just means take your y times 2. 0 times 2 is still 0. And then move it right 2. So if we take 1, 1, take your y times 2, that goes up to 2, and then we move it right 2. You guys see what I'm doing there? So if I have negative 1, 1, my y value here is 1. 1 times 2 is 2, and then move it right 2. Okay, there's my 3 points, that's enough, but let's do a couple more just to make sure you guys understand. If I took this one, that's at 2, 2. Y value times 2 would take it up to a 4, and then right 2. Negative 2, 2. If you take your y value times 2, that takes it to a 4, and then right 2. So we're just getting this skinnier absolute value that's been shifted over to the side. Any questions on that one? Let's try just a couple more that have more than one transformation, and then that'll probably be where we stop for today. It doesn't matter. Let's do this. So what's my parent function? Square root. So square root of 0 is 0, 1, 1, 4, 2, 9, 3. Looks like that. Now let's talk about all the different pieces. What does the 1/2 in front do? Okay, this 2 is under the square root, so that's inside. Inside changes x, so does the opposite. So adding 2 will move it left 2. And then my minus 3. So when you're doing these, save the up and down for last. It would make a difference here, but when we have problems that have flips as well, you don't want to flip or move up and down before you flip. It's going to throw things off. So if I start here, vertical is my y. If I take my y times 1/2, it doesn't go anywhere. Then left 2, down 3. This has a y value of 1, times a half would be a half, plus 2, down 3. Here I have a y value of 2. 2 times a half is 1, left 2, down 3. And I get my graph. Questions on that one? I am going to skip this one. I want to do this one to end with. But I actually do have a typo. I want that cube to be out here. Okay. What's my parent function? X cubed, the chair. 0, 0, 1, 1, 2, 8, negative 1, 1, negative 2, negative 8. So, what's the negative on the outside do? Flip over the x. What's the minus 2? And the plus 1? So if I take a point, 0, 0, if I flip that, does it go anywhere? Move it right 2, up 1. If I take 1, 1, and flip it, it comes down to negative 1. Then right 2, up 1. If I did 2, 8, and I flipped it, it would go down to 2, negative 8. Right 2, up 1. Again, you have to do 3 points, but always have the option of doing more. If I took negative 1, negative 1, flipped it, it goes up to positive 1. Right 2, up 1. So we're seeing our graph now. Something like this. We have covered all the transformation stuff. I have a few more examples that we might go back and hit some on Monday. The only thing left in this section is even and odd and symmetry. So if you look at the very last slide, I did print the assignment. So you guys know we've got homecoming stuff tomorrow, so I won't actually have you in class. This assignment is going to be due on Tuesday. Monday I'm going to finish up talking about the symmetry, and we should have class time to work. I know I taught most of the hour today, but it won't take me the full hour or anything to do that part. You already know how to do almost all of this. I'm trying to look at which ones we haven't talked about yet. I think (19 through 35). Those 5 problems we have not talked about, but the rest we have. So if you want to go ahead and get started on it, you can do the majority. 1 through 4, there's a lot of matching right there. So you can start working on those. You've got a few minutes right now. You can probably get the first couple matching problems done. And then Monday we'll finish this up and have some class time to work.